Ubuntu, and if you want to know why, you can ask me afterwards. So if you want to install it in a virtual machine, then try to get VirtualBox or VMware Player on your system beforehand. If you want to install it on bare metal, then defragment your hard drive beforehand. That can take several hours, if not all night, depending on when was the last time you did it. So make sure you do that well in advance. And then 2 weeks after that, we will be having ALSYS, which is our Advanced System Linux Administration Seminar, which basically, it has advanced in the name, but it's really designed for people who are a little bit past the intro stage. So if you've installed Linux, you've played around with it a little bit, maybe for 2 weeks since, I don't know, InstallFest, then come on in. ALSYS will have limited seating. So if you want to go to ALSYS, that's March 1st. Make sure you RSVP to my email sometime before then. So today we have Nicole Carlson from SpaceX. She's going to be talking a little bit about the company and what she does there. So let's give her a warm round of applause.
Hi everyone. So my name is Nicole, and I have the coolest job of anyone I know. Anyway, I thought I'd kind of give you guys a brief overview of what we do, then open it up for questions. Here's some videos and stuff.
They're initiating the capture of the Dragon. Standing by. Capture is confirmed.
Houston, we got us a dragon by the tail. They actually said that.
Houston, attention, looks like we got us a dragon by the tail. I spent quite a bit of time poking around in here this morning, just looking at the engineering and the layout, and I'm very pleased. So flying up in a human-rated Dragon is not going to be an issue.
So everyone see that? So we do a couple of things then. We made pretty much all of that. The Dragon capsule, which we're currently using to run resupply missions to the International Space Station. If you heard, we just did that in October, and it was a roaring success. So we made pretty much every bit of the Dragon in-house, and we also make the rockets. So we not only make the rockets, which I believe are the very first substantially new designed rockets in a very long time. We design them in-house, we build them in-house, and we fly them in-house. And the Dragon capsule, we also design, build in-house. And we're currently working on getting that human rated so that we can launch our own astronauts to the space station instead of having to hitch a ride with the Russians. So, yeah. I was actually at the launch in October. Oh my God, it was off the book. It was one of those moments that, I spent 4 years of undergrad and 3 years of grad, and moments like this, it's all worthwhile. No, next one. Okay, yeah. So a long road to get here. We started with the first demo flight back in 2006. We've been a company since about 2003, so we're about 10. And we've been flying progressively more flights, I guess. And up until this past May, they've all been sort of demonstration flights just to prove that we can do it. Because it turns out to be really kind of hard to launch stuff into space and return it safely to Earth. Like, there's like several entities on the planet total that can do it. Most of them are state governments, and one of them is SpaceX. Just to put all this in perspective. So, CRS, that was the first resupply mission. I'd been hired by that point, so I got to see that. So I got to see the launch and stuff on site, which was fucking incredible. So yeah, and we launched. We have 2 launch sites currently. One in Cape Canaveral, Florida, where they launched the other shuttles and rockets from, and then one up here in Vandenberg Air Force Base, just up in Ventura County. So hopefully we intend to launch from both of those locales. Stop me if you have any questions, by the way. Just want me to talk about something more. So this is our current manifest, which is a fancy aerospace way of saying launch schedule. So this is our current plan as it stands now. We're doing a few runs for a communications satellite outfit called Unicom. We're continuing to resupply to ISS. The one in October was just the first one scheduled out of many, which are going to take place over the next several years. Then we are not a government, obviously. We're a company, so we have different customers, not all of which are the U.S. Defense Department. The aforementioned Orcom is a private outfit, communication satellites. Then Thaicom is in Thailand. That's the Thailand, the Thai, some sort of communication satellites again. I'm not in that end of the business really. And now from a security perspective, you may notice that if we're launching stuff from Thailand, Taiwan, Hong Kong, these are owned by entities that are not necessarily friendly towards some of our other customers, such as the U.S. Defense Department. So it is my job, among other things, to keep them to segregate these 2 very highly motivated and resource-rich customers from getting into each other's stuff. Let's see here. We're going to be flying another resupply mission, I believe March-ish is the current plan. And after that, we've got the rest of the resupply missions and a bunch of other commercial entities to transport to space. So we're headquartered in Hawthorne, California, which is just out by LA Airport. It's great. We share kind of a rough campus with Tesla, which is our founder Elon Musk's other company. Well, one of his other companies. And I checked, we don't get discounts on cars. But they don't get discounts on rockets, so. So we do most of the building and whatnot in Hawthorne. It's a big building. I several times a week walk out there and see what they're doing on the floor because it's really super cool. So yeah, all the engineering and stuff done in Hawthorne. Vandenberg and Cape Canaveral, those are our launch sites. So we have kind of satellite offices there where people keep an eye on our stuff and our networks and our infrastructure out there. And then McGregor, Texas is our test range. So we do a number of things in McGregor. We're currently testing what we call Grasshopper, which hopefully will be one of the first vertical takeoff, vertical rockets to fly. So yes, we do a lot of testing. Integration we also do in Texas. Integration is, yes.
When you're done talking about McGregor, can you talk about the other locations on the map?
Yeah, sure. Okay, so integration is kind of like when you have a model rocket and you put all the various little parts together, and then you eventually have to put it into one big whole, and make sure that everything's put together right and the parts are aligned where they should be aligned. That's called integration. We do that in McGregor. So we truck the parts out to McGregor, they integrate them, and do the final tests on them there. The other ones, I don't know what they're up to in Houston, actually. Washington, D.C. and Chantilly, those are offices that are primarily there to liaison with the U.S. government, which is one of our biggest and most important customers, particularly the Department of Defense. Yes?
You guys have like 12 underground levels on the Hawthorne facility? Some really cool underground stuff.
We have 1,200 ground level. No, well, it's a big building, and there's, I mean, I don't think there's any areas that are, closed off. No one shall enter here because this is our complex. If that's what you're asking, so I don't think there's that. There's areas where you probably don't want to go because, well, yeah, there's plenty. There is an abundance of bullshit. I guarantee you that, and you're allowed to look at it for the most part. In general, they don't want everybody in the world tromping through their clean rooms. So okay, you have to balance, wanting to look at the cool shit with wanting to not be an active hindrance to what being done. And in particular, one thing we're very concerned about is keeping crap out of the various parts we're doing. It's called foreign object debris, FOD, and it's a major problem because all it takes is one. I should see what they sweep out of some of these components when they're ready to be integrated, and stuff like metal filings, a washer, a nut, stuff that really shouldn't be in a rocket because it can cause tremendous damage when the rocket is integrated and spun up, and parts that were not designed to have a washer rattling around them suddenly do have a washer rattling around them, and that can be it. So in the interest of FOD containment, they also might want to keep you out of some of the more sensitive areas, but not because there's anything so secret that they're going to have to kill you, but because there's no good reason for you to be there, and you could end up doing some damage. Does that help?
Yeah, no, that makes sense. I was just wondering.
There's a tremendous amount of
We might be done. Which is actually impressive.
5, 4, 3, 2, 1.
Oh yes, a tour of the McGregor facilities.
I'm Tom Mueller, Vice President of Propulsion here at SpaceX. I'm proud of the company, and I give a little tour here of our Texas Test Lab. They've been testing rocket engines here since the 40s. We started here in 2003 and have over 130 people now. We average about a test a day. blockhouse. It's an underground bunker. This is where we control engine testing, like the Merlin booster engine. So this is the very first place we ever fired a rocket engine on, was this right here. This is the very early days, first test, so a lot of excitement here. This is a vertical test stand in that the engines fire straight down. So this is a 95,000 pound thrust engine. Basically this engine will burn a hole right through concrete. We have a big water-cooled flame duct that takes that exhaust and deflects it out into the field. This is the small site test area where we have 4 test stands in one place. Right here on the right we have the dual Merlin test stand where we can install 2 engines and be firing them one at a time. In the middle here we have the upper stage test stand where we can fire a full upper stage for full duration as a final check before we ship it to the Cape. And then over here on the left we have the MVAC stand where we do the final testing of the individual upper stage engines before they go into the stage test. This thruster that we're developing here is going to be used on the Dragon spacecraft. So this little engine it's 90 pounds of thrust. It only operates in the vacuum of space. So in order to test it here, we have to run it in a vacuum cell. So you can see the stainless steel cell here that closes up. And we actually operate this thing up to about the melting point of steel, about 2,500 degrees out. This can basically run white hot when we're running this thruster. This is the Dragon module test area where we take one of the 4 quads that's in a Dragon that has 5 thrusters on it, and we can fire those thrusters just like we do in space on the Dragon capsule. This is a hangar where the stage hardware arrives and gets final assembly here before it goes up onto the tripod for final testing. Here we have the tank assembly and the engine assembly. The 2 get joined together and become the first stage of Falcon 9. This building is a central shop. We have engineering up front and workshops in the back where technicians do all the plumbing, electrical, and fabrication of things to support testing out on the test stand. This is the component test stand where we test individual components that go into engines or stage assemblies, things like valves, turbo pumps, gas generators. This is the Falcon 9 structural test stand where we do stage testing of both stages and separation of the stages. Okay, so here we are, well over 200 feet up. If you're afraid of heights, then don't come up here. Here on the big tripod test stand, we fire the Falcon 9 first stage, all 9 engines generating almost 1 million pounds of thrust. The tests last as long as 3 minutes, which is the same as an actual flight duration.
So yeah, and then kind of in addition to the whole rocket thing, we're also heavily invested in one of the first manned crew modules, certainly by a commercial company, and one of the most promising replacements for the now retired shuttles. We kind of designed the Dragon from the ground up to be human capable. We sort of built in a lot of things like abort functionality and whatnot. So we kind of designed it from the ground up for humans, but getting it ready to actually be approved to carry people is a process that we're in the middle of. So yeah, I'm actually involved in that because there are information assurance ramifications anytime you're connecting to a government system. And yeah, you can, I don't know if you can see, but the capsule can fit about like 7 people. They've got like these little hammock, well, they're not hammocks, they look kind of like chaise-longs, and they're sort of in a kind of stacked configuration. So it's small. I mean, it's not a long-term living solution, obviously, but you can fit a surprising amount of people in here, in there. And there's little portholes and stuff for them to look out. Yes.
What does it take to get human rated?
What does it take to get human rated? It takes NASA to sign off on it, basically. Which means that NASA has to be convinced that you're not going to kill people. Yes.
Yeah, so they don't actually have a whole specifications for human rate,
NASA absolutely does have specifications.
And then something that they publish for private companies, etc. They've done that.
Well, I know that it's not just us that's going for human rated space captains. There's a couple other companies, one called Sierra Nevada Designs that has kind of a plain design. And then ULA, United Launch Alliance, which is the bastard love child of Lockheed Martin Boeing, has one as well. So yes, there are specifications, and our job now is to demonstrate that the Dragon meets them. So in your enormous checklist, you go through and you say, does it withstand so much pressure? Check. Is the stress test not less than such and such? Check. And you just have to conclusively demonstrate to NASA that you meet all of their requirements.
So,
And if you do it from another country, do you still need NASA's approval?
If you want to carry NASA's astronauts, you do.
so would the Virgin Galactic split play?
I believe that is I'm not 100% familiar with this, but I believe that the Virgin Galactic Spaceplane is kind of a different project. It's designed for high suborbital flights and not necessarily rendezvousing with the ISS.
Yeah, I didn't know if it was under the same classification though.
Here we get into arguing about the definition of space and where space begins and what suborbital means, and honestly, I don't really know.
How long do you think before the Dragon gets human rated?
How long before Dragon gets human rated? Probably a few years. I spent my career before SpaceX in a more government environment, and things move extremely slowly in government. For one particular type of certification, 18 months is considered an extremely ambitious schedule. So stuff does not move fast. It's enormously complex. There's a lot of stuff to be done, and you have to get basically you have to get everyone to agree on what the requirements are, what they mean, whether they're applicable, whether they're met. So there's a lot of arguing that goes on kind of behind the scenes of what would on the surface appear to be a fairly straightforward thing. Does it meet these requirements? Check, check, check. In reality, you have to get everyone together to agree on what the requirements mean and what it means to fulfill. So yeah, it'll probably take another 3-ish years. Yes?
You mentioned earlier that this is one of the first rocket major redesigns in a long time.
Yeah.
What's so different?
I'm not actually a rocket scientist, so I don't really know. I do know that your Saturn V's and whatnot are sort of built around one giant thruster. We're built around multiple smaller thrusters. And here we take leave of my humble knowledge of rocket design. I am not too conversant with rocket design. Oh, yes?
What part of the rocket do you work on?
I am an information assurance engineer, so I work on no part of the rocket, if you will. I work kind of on the systems that support rocket launches. So obviously, if SpaceX is sitting in mission control in Hawthorne, which is where it is, and like you saw in one of the earlier videos, everyone's going nuts outside. That's in Hawthorne. We're communicating with the Cape Canaveral people. That connection obviously has to be free of interference. You don't want I don't want some joker to substitute his instructions for ours. I don't want some joker to, God forbid, launch the self-destruct thing or whatever. So that connection has to be kept secret, and it has to be kept, I have to maintain the integrity of the connection. So you can see that it's, even though it's not part of a rocket or Dragon per se, it's kind of important to the whole launching of them, if you will, and so that's more my area. And maintaining our internal networks so that different parts stay out of each other's way, basically, and yet people still have the ability to do their jobs. So the answer is no part of the rocket, but it's important nonetheless. So I believe that's meant to be a mock-up of the ISS.
I think it's different.
These squarey things here are solar panels, which is also what these are. Give them some wind power. And you can see it in the animation up here. You can sort of see Earth kind of drift by. This is from when the Dragon was attached to the ISS. We've got a camera on it, and it was recording this. Here's the one. So that's meant to be the separation of the first stage. The first stage is the bit that fell off there. There it is, crumbling back down. Currently, all rockets use this kind of disposable first stage. We're trying to develop a reusable first stage, which is kind of the holy grail of aerospace. So, yeah, this is what I was mentioning earlier. First, vertical takeoff, vertical landing. Here's the Dragon separating from the second stage. I think the second stage is still disposable. No very good way around that yet. And here's the re-entry of the second stage.
And this is showing it's reusable.
I guess we are reusable. If we can get this to work, it will be a huge step forward in rocketry. Because a lot of the cost of the launch right now is because we have to dispose of those stages. And you have to fire a new one each time. I know they look like wings, but they're solar panels. There's no air up there, you don't actually do it. And there's the Dragon attached to the ISS. notice it's shaped kind of like a muffin with the top cut flush, and it's entering with the muffin top down. There's a bunch of what's called native coatings there, which are designed to burn away the heat. Right now, Dragon lands by splashing down in the ocean. We can get vertical landing, but that's another huge step forward. Yes.
When you said that right now Dragon splashes down into the water, like who recovers it? Navy or?
We send out a boat.
One of SpaceX boats?
I think we charter it, but I know that like there's SpaceX engineers and stuff who have locally. We can send out an and yeah, they go. I mean, they know roughly where it is. The reason they splash down in the ocean, by the way, is because the ocean amounts to an infinite runway with an infinite capacity for heat absorption. So yeah, they splash down. They know roughly where it's going to splash down, and they send the boat out like 3 days ahead of time, and it just kind of hangs out there until it sees it and then goes and retrieves it. You may have seen some shots of the boat retrieval in earlier videos. You saw a boat and people pulling it, something aboard. That was the recovery of the capsule. Yes.
Have you guys actually had the first stage land vertically before? Or?
No, we have just had a successful what we called a hover test in December, where the thing took off. It kind of hovered at a few stories altitude and then dropped back down. So I think that's an important milestone. There was a little mannequin on board, and the mannequin came through okay. So it was so the takeoff and landing was delicate enough to not jostle the mannequin. So we think we're making progress. Yes.
Is there still any interest in naval using a ship as a launch platform, or is that kind of been thrown out the window?
Again, I'm not the right kind of engineer, but my instinct is that it would be extremely difficult to launch a rocket from a boat, just because not only do you have the intense heat, as I think they mentioned earlier, it's hot enough to melt concrete. So not only do you have the intense heat generated, and you'd have to have a boat capable of withstanding that, there's also the tremendous downward pressure exerted by the rockets, which I'm thinking of a toy boat in a bathtub pushed down real hard on one end and it just kind of squirts over the water. So while I'm not saying that would happen, I think it would be enormously difficult to launch a rocket from a ship. Yeah. Oh, okay. That was a hover test. That was a previous hover test where, as you can see, it just kind of took off and came right back down. The one we did in December was a slightly longer hover test, but yeah, that was a hover test. So yeah.
So how do we work there?
How do we work there? I'm so glad you asked that question. I would love your resumes. We're looking for summer interns, also potentially for real jobs if you're looking for that. Unfortunately, at this time, you must be a U.S. citizen, or I think you can be a green card holder. Sorry, it's because we do so much Department of Defense stuff. It's one of the things that gives the if the federal government were a person, this is what it would lie awake at night worrying about, is the possibility that some of its contractors are not clear U.S. citizens. An irrational fear, perhaps, but that's another story for another day. So I'm afraid you must be a U.S. citizen or green card holder, yes?
Even for internships?
Even for internships, I believe.
Security clearance, those required?
You do not need a security clearance. It's helpful if you have one, but you do not need one. And then I would like to take your resumes if you have any. I'll leave my email address with Zach, so you can email them to me afterwards. Where my department, InfoSec, is kind of looking for a person who has a strong background in security, but also knows their way around IT a little bit, because that's kind of a void we have right now. Or potentially if you don't have that, but if you're really, really good at data mining, then we would also love you.
Guys, thank you. If you still need to sign the scale forms or pay, come see Chris, because we have to have that today, or we have to drop it from the list because it's due today. So thanks, and we'll see you next week.